Okay, I think this is good. Let's make sure we've got at least some of this stuff set up. There we go. I don't know why I put my headphones on. I don't really need it. There won't be too much sound. Um, what is up, everybody? It's 2025. Great to see folks here. We are going to do something a little crazy today. We're going to build an HPC cluster, or that's the plan anyway. I was hoping I still had my old one laying around, but it doesn't look like I do. So without that, I can't cheat, I guess would be the best way to put it. We'll have to do it from scratch. No big deal there. So that's what we're going to do. We're going to at least attempt to build what do we got here? We're going to attempt to build a cluster using OpenHPC. We're going to try to do yada yada yada. We're going to try to get the head node done, and that's pretty much it. Let's go check over here. Interesting. So yeah, okay, they've got it. Let's see what they've got up here. We'll be using Werewolf for the imaging, and we'll be using Slurm for, obviously, Slurm things. So let's see here. I'm looking at the documentation currently. That's not what I want. What I'm hoping is this is maybe newly updated documentation, and it's using the newer version of Werewolf, but it does not look like this is the new version of the documentation. So that's fine. Let me check one thing here. Oh, let me do this. Put this up here so everybody can see it. So this is the documentation we're going to follow today. This is the OpenHPC cluster building recipe. We're going to be using Rocky, apparently 9.3, so I'm going to have to go download that. Rocky 9 download. Grab that real quick. And we'll have to... This should be fine. That'll take a minute. I wanted to see what version of... Oh, we'll go here. Install the base operating system. Check, install components. Let's see, where's the Werewolf documentation? Here we go. It looks like they're still using Werewolf 3, which is fine. I do like Werewolf 4 a bit more. But this is okay. We'll basically be following all of these instructions in a lot of this information here. Some of it I change. I do not like this. And we'll kind of point that out as we go. Okay, so let's get here. Let's make sure we're getting this downloaded. How are we doing? Oh my goodness, that's going to take a little while. So this is all new terminology to me. I'm intrigued. Okay, so let's start with, that's a good idea. We can start with terminology. We don't need our TrueNAS box. So HPC, high performance computing. This is clustering systems together to do large computing tasks. So large Python programs to sort of solve different questions. Oh, well, do we have different mirrors? I mean, it's already half done. We can go over terminology while that's going, so we're not going to stress it. You use HPC in kind of you have a head node, a brain, where everyone logs in and there's storage and packages and software, and they access different software to solve different problems. So like, for instance, there's software called Gaussian, which does some sort of math related things. There's stuff like Charm. There's stuff like 3D renderings. Ansys has some tools. There's a company called Ansys that has tools to basically run simulations on different materials, so you can kind of see what the output are on those things without having to, wait hours and days and months and years. Because if you run it on a single machine and maybe you've got a GPU or something and it can do some of the work, but maybe it's not a big enough one, you can use cluster computing and just kind of dump it on a giant piece of hardware, and let it kind of work so you can continue to use your regular machine. That being said, a lot of what I use is high RAM, high CPU. We do have some folks where I work that use GPUs for machine learning and AI type things, more in the having them review data and see if AI can see what's going on. So that's kind of the baseline of HPC. So while that's going, I also need, let's see what I also, yeah. Oh, I've already got it downloaded. Cool. So there's Rocky 9.4 ISO DVD. So the first thing we're going to have to do is we're going to have to build a virtual machine for our head node. We're going to make this one kind of small. It's not really too big a deal right now. We're going to call it head node. The OS is going to be that ISO. This is fine. And of course, this is Proxmox for those that don't know. We're just using it as a virtualization layer. Usually in HPC, you don't do virtualization very much unless you are going into sort of really parallel processing. You would rather use, at least from what my experience is, you would rather use what you would put a hypervisor on as a single compute node and buy a whole bunch of those. For instance, one of my clusters at where I work has 10 nodes that were previously VMware hosts. So they've got 128 gigs of RAM, they've got dual socket processors, they can crunch through a lot of data really effectively. Now that's kind of a tiny cluster for real research environments, but for what we do, super easy. We don't really need this. We'll go ahead and add it. Disk, that's fine, that's fine. We're gonna make this 60. I'm not too picky about any of this changes. Next, one socket, dual core. That's fine. Memory, 4096. Next, network. This is where I wish I had remembered. We'll just put it in VLAN 30. It's fine. I don't think I have to put a tag. I might actually have to put a tag because I don't think I'm running SDN. We'll figure it out in a second. It's been a while since I've done this. So that's going to spin up our head node VM. And there it is, getting all prepped up. We'll pop over to the console. Uh-oh. Start failed QEMU exit. What did I do wrong? Oh, I know. This probably needs to be turned off for right now. So here's our first issue of the day. Why isn't Proxmox letting me make a virtual machine? What have I done wrong here? Let's edit this. Let's set this to host. I don't think this is the problem. Let's Google it. QEMU exited is row 1. I don't even have anything to boot on yet. Very strange. We are literally trying to boot off of an ISO. Aha. I don't think that's gonna fix it because it's like mad. Yeah, what's going on? VLANs are not allowed on VM. Oh, okay, there we go. If we would just read, we go here, edit this. Maybe we don't need this. Let me check something real quick on our networking configuration. Do we actually have SDN configured? Oh, we do. Look at that. So there, that problem is sorted. I'm a big dummy. Ta-da. So first thing we're going to do is we're going to install Rocky. I think I can blow this up a little bit. So folks can see it. Wow, it's just refusing. So we won't worry with it. And of course, this will take a little bit. And while we're doing that, we will go through our documentation, which is pretty much just going to say install the SSO. We'll be doing a standard install. We don't need this page anymore. And this will take a couple minutes. I hit the check media. Gross. I hope everybody's had a wonderful break, a little holiday break for everybody who's been in IT world. I know it's now is the time of year that we kind of get off. Some people don't, though, problematically. There were plenty of sysadmin events in the news during the holiday break. There was the computer system outage for, what was it, United? And then we saw the VMware suing, or Netflix is suing Broadcom over VMware. That'll be interesting to follow. We'll probably cover that a little bit more in the new year. What else has been going on in sysadmin land? Oh, there was a big vulnerability for Active Directory that just came out. So that's getting patched for a lot of folks because everyone pretty much always uses Active Directory. Though a lot of places I think are, at least we're moving more towards Entra. So we won't have to have domain controllers, hopefully in the foreseeable future, maybe in the next 10 years. Nothing like that. So we'll see how that goes. We're almost done with this check. But let me know what you're working on in the IT world these days and what you're seeing, what you're doing. As we wait for this to load up real quick. Check my messages. Nothing of use in there. Do. What is this? Oh. This installer's taking its sweet time. I don't remember it taking this long before. But I also haven't done a bare install of Rocky in quite a while. So we're English speaking, so we'll keep that. Hello, mouse? Oh, man. We're going to be doing this, eh? Oh. Location, cool. Destination, yep. We're going to let it just do its own thing. It's fine. We do not need the GUI. We just want server. We won't be using the GUI at all. That's good. Time and date, that's fine. Cool. Let's set a root password because we will need this. I won't be SSHing as root. You're a VMware user? Hey, I used VMware for a long time. Not my jam, but no big deal. And then we'll go ahead and we'll make ourselves an account. We're also going to make this user an administrator. I don't think I need to. Nah, I don't care about any of that. Here we go. We hit begin installation because this should be pulling an IP address. Yeah. Can we? This will just, oh, let's set a host name. We'll call this head node. So it is grabbing IP address 30.2. So no one else is on this network IP. We'll do that inside the system later because it's probably going to reboot anyway. So we'll begin the installation. We're just building a basic Rocky 9 box with a little bit of storage on it. This will be the head node. So this is where users would log in. This is where their home directories would live. This will be where the software resides. And it will have, essentially it will have some sort of file share style, whether that's an NFS share. Usually it's NFS. That's what we'll be showing off in this documentation, if I remember correctly. And it'll be sharing out the home folders so that when you start a job, all of that is mounted on the compute nodes so it can access the data to write and put in outputs and explain everything, and just give their outputs to your individual users that are running jobs. Usually this is backed by a much larger piece of storage instead of, we'll probably maybe add a second disk and give it like another 100 gigs just for fun. We will need to add a second network interface on this device as well, because how HPC works with the way I've learned to do it is you have one kind of external interface, and that's the one that users are able to SSH into or access a web GUI if you're running any of those web GUI type tools for your HPC. And then an internal network that it actually manages itself. So we'll have a dummy network that exists that isn't part of Proxmox or anything like that. That is kind of like a 10.1.1.1 type network, or a 172.30.1 or something like that. That is, just for the cluster, so that compute nodes don't go out to the internet. Users can't access compute nodes directly. They have to access it via the head node, stuff like that. We'll also be installing some software I really like called Spack, which is a fairly simple way to get scientific software installed on your cluster in a quick and sometimes dirty manner. It's not the best thing in the world, but for someone like me who doesn't get to do this for 8 hours a day every day, I get to do HPC as one of multiple job responsibilities. I don't have time to put a lot of effort into learning how to compile every little piece of software and things like that. Luckily, there are people that build recipes that handle all that for you, get all the prerequisites for you, much like Yum, essentially, but for scientific software specifically. And then you configure it to put it in places so that, again, the compute nodes can access it so they can run that software on themselves through the NFS share to generate the data that the researcher is looking for. So we'll do that too. We might be able to get to compute node provisioning. It kind of depends on how long I want to go today and how interested people are in it. If we get a lot of people coming in and, doing silly stuff like super chats, then we'll just keep going until that kind of dies out, or we finish the cluster. But we'll at least get the head node done during this live stream. And that will actually probably take quite a bit of time, because it's been a while since I built one of these. I think I did this one time last year, and I did it kind of in a rush for y'all. So I had a lot of people asking me to do another one of these kind of video series, but I thought, I'll do it as a live stream because I haven't done one in a while. And then if we need to, we can take snapshots, add resources, make clones, all that stuff, things like that to kind of protect this. But that's kind of the layout of what we're doing today. Usually all of this is done on bare metal hardware, unless you have some massive hypervisors, because realistically you use all the resources for the compute projects. But we're going to have a very small cluster that really won't look all that great from a researcher perspective. It will look too underpowered. It won't be able to really do anything any faster than a quad-core desktop with 64 gigs of RAM. But I'm just wanting to give everyone the ability to see kind of how one of these gets built. Now, I will say this setup uses what's known as Werewolf 3. Werewolf 3 is a provisioning software, so the head node will actually be what spins up our stateless compute nodes. So the compute nodes don't get like a hard drive that stays installed and all that. They keep a small hard drive for like scratch space, but most of the time the OS is really just loaded into the RAM. So you give them a little bit extra RAM, and then you provision nodes, and they just, on reboot, they pull down their ISO again. They get installed with a custom image that's been set up on the head node, and they're clean and fresh for anybody to use anytime they need to be rebooted. And you can also set up multiple images of stuff like Werewolf. So let's say you've got multiple researchers, and maybe one person wants to use Rocky, one person wants to use Ubuntu, one person wants to use, I don't know, something with Docker installed or things like that. You can build different images that are pre-compiled in different ways, so that if you need to change compute nodes at any time, you can just say, change this node to this OS so that this user can access it. And then it'll flip it over to the different type, which is really cool. I also thought I'd do this as a live stream so that people can see exactly how long this kind of stuff takes. Now, it is kind of unfair that, you know, we're doing this on old hardware that's running Proxmox, so it's going to take even longer, but it's not too big a deal. While that's going, I will go ahead and make our VMs for our nodes. So we'll go create VM, we'll call it node 01. Actually, we'll just do node 1. Next. Do not use any media. Next. 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 We actually won't put it on VLAN 30. This will make more sense in a little bit. Next. Finish. So we'll start with one node for right now, just so we have it there, so it's referenceable, but we won't really be doing much with it. And then while this is also going, we need to add a network device, and it really needs, I need to be able to change this. It just needs to be a dummy device, and I can't remember what to set for a dummy device. Well, let's leave it alone for now. So now we got the two network devices on the virtual machine. This one is real and important. This one is not going to be real. Let's change that VLAN just so I don't forget that. Bloop. This one is going to be for internal communications. This one is going to be for external communications. We're running 4 gigs of RAM, 2 cores on a single socket, which is more than enough for what we're doing today. And that's pretty much it for the head node. Once the OS is done, we can really start getting into the meat and potatoes. But so we'll go through some of the initial steps here while we're waiting to. So you install the OS. It makes you put in the IP address. Now they're going to use some of this nomenclature here, which I don't care for. There's information here. They call it SMS server, internal Ethernet, provisioning interface, internal network, internal. I wish it was a little bit different. This is kind of, what's the word? It's not scary, but it's a little off-putting. It's a little weird for a lot of folks to see, at least from my point of view as a sysadmin. I wouldn't put this. I'd put like head node name, head node IP, head node Ethernet, interface internal. But anyway, basically this first command is pump in the IP address and the host name of your head node into Etsy hosts. And the reason you do that is you're going to be pushing this Etsy host file to everything. Plus, you're not going to be doing too much related to external DNS. The head node is going to become DNS and DHCP for all of your compute nodes. And then it recommends to disable SE Linux, which we'll do, but I noticed that it doesn't actually show that command. So I kind of wish they would do that. And then lastly, they also mentioned to disable Firewall D. I do not agree with this step. You should leave Firewall D on and configure your interfaces properly. So you know how, and we'll look into it a little bit when we pull up a Linux machine in a few minutes when this is done. The firewall has multiple zones, public, private, internal, external, DMZ, stuff like that. You'll want to configure each interface on one of those zones and then use that zone to allow communication traffic. So like your public zone, you're going to open port 22 so that people can SSH in. And then on your internal network, you're going to open the ports for DHCP, FTP, HTTP, anything like that to your compute nodes so that they can talk to the head node. because we'll do things like monitoring, so we can make sure that the head node gets information if a compute node is down for any reason and can send that information to you as the administrator to go fix said thing. And then once that's installed, we're going to add the OpenHPC repo. This is, yeah, no, that's right. Is this the right guide? This throws me off. I don't know why. Then we'll go through some basic installations. We'll install OpenHPC Base, OpenHPC Werewolf, and HWLock OpenHPC. Now, I do want to mention, you do not have to use OpenHPC. There are plenty of other options out there. There's XCAT, there's Bright. Bright costs money, and it costs a lot more money now that NVIDIA owns it. Or you could do all of this with the same packages that OpenHPC recommends without using the OpenHPC repo. It's just that these packages have been picked together through OpenHPC to work together properly. So they know that these versions of the packages are going to work. They know that the versions of these software choices will work together so that you don't have to worry about that. And then of course, if you're running physical hardware, you should set your IPMI so that you can access the consoles of the machines should you need to remotely, because no one likes to go in the data center anymore and plug up a crash card. Let's see how we're doing over here. Oh, we're done. Let's hit reboot. Actually, let's go to options. Let's change the boot order back to SCSI first. Hit OK. Reboot system. Once we get rebooted, I'll pull up an SSH window so we can see this a little bit cleaner, because it's really small right now, I'm pretty sure, for everybody, and I feel bad about that. That's what I thought. Let's go to options. Let's go to, where is it? Actually, we can just edit this, turn this off, go to hardware, edit this, actually remove it. We don't need the CD-ROM. Let's not remove it, remove it. Let's just hit that. There we go. It's gonna cry a little bit. That's fine. We're gonna hit the old reset button. Boop. There we go. Now with booting, we'll get in there and we'll find out what our IP address is, because it's not set statically currently, so it might pull a different one, but it should pull .2 because it's the only device that's on in this network right now. We can ignore that. And there we go. Let's log in with, how would I set it to? Plug it in as root. What did I set it to? Oh, it is. Yep, 192.168.30.2. All right, so before we do anything else, let's pop down a snapshot. Oh, I forgot. That option is not there, this one. More. Nope. Gotta go here. Take snapshot. Base install. Do not include RAM. Oh my goodness. No spaces. There. All right, snapshot has been taken. So now we have this nice clean thing. Let me go down here. Pull up an SSH terminal. 30.2. And then let's get this up here. And make sure y'all can see it. Window capture. There we go. Voila. All right, so here we are on our head node. We've got our IP address there. First thing I want to do is make sure that that does not change. Don't like We're not going to do any domains thing. Unable to. Oh, crap. I didn't hit sudo. We're going to be spending most of our time in here anyway, so we're switching to the root user. And we're not doing any fancy. Okay. We'll go ahead and do updates before we start adding in stuff from our document. So while that's going, we'll pull this back up. We'll go over here now. Go back to the top. And let me know if any of this doesn't look clear enough. If you'd like something larger, I can do that. You can zoom in a little bit. It's not too terrible, right? All right, cool. I love that YouTube they have goals now, like Twitch streaming, but it's all monetary stuff, and it feels kind of weird. I don't know about y'all. I don't know how much Twitch you watch, how much YouTube streaming you watch, how much you support content creators directly or anything like that. But I can't set like a fun goal, like get 100 subscribers. It's super chats. And it's kind of crazy. I could set some streamer goals, such as I'll stream again on Friday. I'll play a rhythm game without any sound. I'll host a community gaming night. Get 1 extra hour of live streaming when we reach the goal. I'll do a stream where we explore more indie games. So it's all kind of gaming centric, which I get. That's sort of how all this caught on. But I don't know. What would be some system administrator related chat goals? I don't know. Seems weird. If you want to support me, you know how to support me. You can hit the like button. You can subscribe to the channel. You can tell people to come watch my videos. And you can leave comments in the videos, because that's a really good way to grow community, you know? Don't get me wrong. If you want to send me money, send me money. But that's not the point of this channel. This is mostly a hobby. We're currently patching our head node to get it ready. While we do that, I'm going to take a look at our sysadmin. Let's see what's going on there. If I see anything good, I'll post it in the chat. SAS hard drive part number help wanted. No. Do I have this set to new? I do. Affordable integrated ticket workflow system. MSP advice. Not much going on sysadmin, but it is Saturday, so we'll check the HPC subreddit, which bigger than I expected. SchedMD support complaint question, cluster question using a Xeon Phi. I never got a response from this person. I tried to help them out with their GPU stuff. Running Gen AI on supercomputers, bridging HPC and modern AI infrastructure, which I kind of thought they were already doing. I guess they aren't. Anyone deploy LS-DYNA in a Docker container? Oh my God. So LS-DYNA is a piece of software that is used to research material stuff. Like I had a structural researcher who was testing different metals and how they crumpled and broke in relation to airplanes and flight systems and stuff like that. So running that in a container doesn't seem benefiting because it needs so much power to solve all that stuff quickly. I guess if they were running small jobs in LS-DYNA, I could see them using a container. That's not really my job. There is a lot of stuff you can do with HPC, and they use a lot of different things. I will not be showing off a lot of it because I don't deal with it a lot. One thing we're really missing out on here that I like to bring up is InfiniBand networking. It's expensive, but apparently it is one of the best things latency-wise for researchers, because a lot of what's going to happen is communication via the network to storage. You use your InfiniBand links to talk between compute nodes and the head node, and sometimes if the storage, there might be a storage node in between the head node and the compute nodes. That makes things a little bit more confusing, but it works. It works fine. And it lets you have some more mobility with your head node. You can just kind of stand up a new one if you need to, move your switch, your networking configuration, everything over to it, and it just takes over. So there's that you can do. But I love InfiniBand networking, but it's expensive because, again, NVIDIA. What else are we not going to get to show off here? I don't have any GPUs, so I can't show you how to use stuff like CUDA cores or any of the NVIDIA packages to run stuff like that, but that is a big thing nowadays. We actually have a class that is learning about that now, and it's really cool that the professor has picked up on it and really sees great benefit, really interesting stuff from that. So that's pretty cool. And I do apologize if I don't switch windows instantly. If I'm referencing something and I miss it, just say so in the chat and I'll put it back on there. I think the chat is it's a little delayed, but I run full Linux now. I'm running OBS on Linux. This is my first time streaming via OBS in a long time. I used to use Streamlabs OBS, which is just simplistic, but a resource hog, and I don't think it works in Linux. I'm not sure. But OBS works great. There's plenty of plugins for it. Enjoying some sweet tea, as one does. We've got a crap ton of snow up here too, so I don't want to go outside today, but I have to go outside today. My mic is clipping just a little bit. I'm going to drop that down just a hair. For those of you just joining us, we are getting a head node installed. We have not begun utilizing OpenHPC yet. We are still in the process of patching the Rocky 9 ISO to get it as up to date as possible. Not a whole lot going on right yet. Networking is configured for this host, but only one of the network interfaces. We've still got to do the other one. And like I said, the other one will be an internal only interface. It will have a fake network, and it will talk to the compute nodes that also live in a fake network. Now, obviously, if you're doing a physical one, you just do a flat switch. Everything plugs into that switch. Everything just talks together. Because this will be the gateway. Golly, brain's frozen. It's been a while since I've been at work, so I haven't had to use my IT terms in a while. big thank you to everybody for coming out. It's really nice to have people here. I was not expecting that, so I was super happy. And I hope this is informational and entertaining. We're on the last little package piece here. And of course, we'll have to give it a reboot because you should always reboot. About to go through a similar process soon, trying to set up Red Hat OpenShift in my home lab. That's why my work decided to go over more alternative. Oh, let me know how that goes. I haven't really messed with Red Hat OpenShift. I should probably at least give it an attempt, a try. It's not something I'm super familiar with. It didn't really fit our environment choices at the time, so I can give you guys an update on that if you are interested. So in case you weren't aware, I did some videos about how my workplace is switching from VMware to Proxmox due to all the VMware pricing stuff and things like that. Realistically, based on if you knew the history of our environment, we had a chance before any of the VMware stuff happened to just go full in Nutanix because we were running Nutanix at the time, so there was no reason that we shouldn't have switched. We were considering migrating fully to Nutanix because we had heard that our contract deal with VMware was going to go up. This was pre-Broadcom. It didn't go up, so we said, all right, we're going to go full VMware because we're getting a good deal on VMware pricing. Then Broadcom took over. Sadness, sadness, sadness. We were in a weird situation where we were going to have to commit to 5 years. And we didn't have the confidence in our funding to say we can pay for 5 years worth of VMware. So we were like, all right, we're bailing. We're going to Proxmox. We have migrated everything off of VMware that we absolutely can. And it's running pretty well now that we're on our proper hardware. It's been laborious, and a lot of my team put in a lot of hours. They did a great job, and we're super happy with Proxmox. We're getting what we need from, I know a lot of people don't like the Veeam integration quite yet. It is still limited, but it is covering what we need to do, which is simple backups and restores. So let's look at your stuff. I'm not looking forward to it. It seems like they mostly advertise as being for development, and VMs are an afterthought, and we're 100% VMware shop. Application, yeah, that's kind of why we didn't feel like OpenShift was a good fit for us. We don't develop anything. We don't spin up containers like that. We don't have a fluid server workflow because we aren't a service provider other than education. So OpenShift didn't seem like it was going to meet our needs, but I think it definitely meets needs for people. I think there's a fit there for a lot of folks. I know a lot of people also switched from VMware to Hyper-V. Makes sense if you're Windows shop and you're just like, we do Windows and that's the most thing we do. Hyper-V, sure, go for it. I don't like it. I'm not a fan, but I can see it fitting the need perfectly fine for a lot of people. And then other folks went XCP&G, which I've also heard a lot of great things about. We saw Proxmox because we were mostly hyper-converged because we'd started as a Nutanix shop, and then we went to a vSAN shop. Proxmox was really pushing the whole Proxmox plus Ceph, HCI. That looked like a good fit for us, so we went with it. Let's get this rebooting. Oh no, I got kicked off. So we'll reboot that real quick. Hopefully it keeps its IP address because I think I saved everything properly. It's been a little bit. We'll give it a second here. We'll see if I can back up. I'll be sad if it doesn't. It shouldn't change. Again, it's the only thing on this network right now. There we go. Got to. Let's check our free space here. So it put 18 gigs in home, 37 in root. That's fine. Nutanix was really the only other approved option for us, and that cost nearly the same as VMware. It did cost the same as VMware, and they're really kind of picky about their hardware certification. You have to buy the specific Nutanix hardware, which kind of means you're locked into them 2 ways instead of just one. I don't think there's any problem with the AHV setup. I like it, but again, it was kind of cost prohibitive to us. We were already looking to shrink our VMware footprint in general before Broadcom had kind of come into play. So it was really just more of a, well, I guess we're going more Broadcom. All right, so let's pop over to our document. I think I can just hit that. Yep. All right, so as you can see, our first step is to do echo SMS IP, SMS name, boom, boom, Etsy hosts. We can do it like that, or we can do this. Let's go back to root, because I don't want to deal with any of that sudo nonsense. I didn't type that right. There we go. So we just do 192.168.30.2. What did we call this thing? Head node? Yep, head node. All right, so that step's done. Next step. Oh yeah, disable SE Linux. So in case, for those that want to know, in case you're not very familiar with Linux, SE status is going to show you your SE Linux status. It is enabled, it's enforcing. They want us to completely turn it off. So we'll do this the way you're not supposed to do it. Etsy sysconfig SE Linux, or at least I don't think you should really do it this way. But we will set this to, they used to have the info in here. Targeted minimum MLS. Where's disable? Would work fully. If you need a system SE Linux full disable instead of SE Linux running with no policy loaded, you need to pass SE Linux equals zeros to the kernel command line. You can use Grubby to persistently set the bootloader with SE Linux. Huh, okay, cool. So this changed. Up to RHEL 8 release included SE Linux disabled. But also, if you need a system with SE Linux fully disabled instead of SE Linux running with no policy loaded, you need to pass SE Linux 0 to the kernel command line. So we can do this. I'm going to do this anyway, just as a safety net, and then we will also do this. So we'll pass that line like it said to do. And then we got to reboot again. I don't think I have ever run any vendor documentation that doesn't start with disable SE Linux. Oracle tells you to do it. This tells you to do it. And it's really not that big a deal. There are SE troubleshoot commands and things like that that will, you can set it to, instead of enforcing, set it to permissive so that stuff runs. And then SE troubleshoot will dump out the information on what you need to run to then make the software start working once you enable SE Linux to enforcing. It takes time, but it's what you're supposed to do. Now, I'm definitely in the camp of just disable it because I'm lazy. But that's not the right way. Okay, so we did that step, even though it is not properly listed in the documentation. We disabled SE Linux. The next thing, again, they say to disable firewall D and stop it. I will do this, and I guarantee you we will have to turn it back on at the point we get to talking to compute nodes. Systemctl disable firewall D. Bye-bye. Systemctl stop firewall D. Bye-bye. All right. Firewall D is off as per the documentation. Next thing, we are going to enable the OpenHPC repository for local use. I want to check something real quick because I feel like that line concerns me. I may just have the wrong thing. Yeah, we have the wrong document. So let me grab the right document. Oh, wow. Oh, they have a version with Werewolf 4. We're totally doing this. I just needed to read a little bit further. This is what we want. Scroll, 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 scroll. This is all basic information about what is in a cluster, which you should all read. I've read it. It's fine. They still do the same thing here. I hate it. Disable firewall D. Disable SE Linux. Again, first thing. All right, now this is the proper repo we need. We want the x86-64, not the Arch 64-bit. So we'll go over here. We will pop this bad boy in. We trust it. So now we've added the OpenHPC repo and EPL actually. So let's see what's next. The next thing, many sites find it necessary to maintain a local copy of the, you should also do that. If you can't let your compute out to the internet for whatever reason, which is a thing. In addition to OpenHPC packet repository, the master host also requires access to the standard base OS distro repository in order to resolve necessary dependencies for Rocky 9.4. The requirements are to have access to base OS, AppStream, extras, CRB, and EPL repositories, for which mirrors are freely available. We'll go ahead and pop in these commands because we have to have them. So we'll grab this first one. And then while that's going, I will go ahead and highlight this next line, which is going to enable CRB. Now I do have networking limitations. The switch that's downstairs on this hardware is only a 1 gig switch. It's not a 10 gig switch. I would love it if I had a faster switch. I don't have the money to justify that at this time. I'm running on very ancient hardware. Okay, and that step's done. So let's go back to our documentation. Installation template. The collection of command line instructions that follow in this guide when combined with local site inputs can be used to implement a bare metal system installation configuration. The format of these commands is intended to be usable via direct cut and paste, which is kind of nice. Blah, 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 blah. Add provisioning services on the master node. I cannot wait to show you guys this. Werewolf 4 is decades better than Werewolf 3. I love Werewolf 3. It works great, but this comes with 4. I'm so happy. 4 makes it, I don't know, for some reason it works in my brain. So we'll grab the base, Werewolf, and hardware. I will again say, you do not have to use OpenHPC. If you want to, you can just go through every little package that they're installing and grab it from regular repos instead of the OpenHPC repo. The reason we use OpenHPC is because, again, like I said, we trust they've already done all of the work on the back end to say that these versions of all these packages definitely work together fine. We're happy with these versions of the packages together. We will update OpenHPC repo as we test and validate that there's proper interoperability between these different packages. So that's really cool. But you could follow their documentation and just grab the packages you want in particular, which I've kind of had to do in some situations. I've used OpenHPC mainly for those that are aware, to migrate from Bright clusters, because again, NVIDIA, super expensive, to OpenHPC stock clusters, which has sometimes had to require me to just install the packages without installing the OpenHPC repo, but I still call them an OpenHPC cluster. All right, that step's done. Back to our doc. So this one, again, if you're working with physical hardware, which a lot of people are, you should probably get this configured. Or if you're comfortable configuring your IPMIs, your iDRACs, things like that yourself, make sure you get them set up properly. HPC systems relied on synchronized clock, so this is true. Let's turn on Cronny. Excuse me. Should be on. All right, so that enables the service. And then we're going to set a local stratum of 10 into cronny.conf if this doesn't throw an error. Now, again, we are following the documentation to a T. And it wants me to echo server ntp server etc cronny.conf. So let's find a good NTP server. Local NTP server for time synchronization. So it's just going to be itself. So I'll copy this line, which is going to be weird. This will probably need to be the gateway. No, it can be the head node IP. I think this is fine. I don't think it's going to be a problem. And then we're going to allows all servers on the local network to be able to synchronize with SMS host. Alternatively, you can restrict the access, fixed IP ranges, example config, blah, blah, blah. Okay, that does need to be the internal network. So I need to change that. We're going to set this to 10.1.1.1. That's going to be an internal network down the way. And we're going to allow all in there, and then we're going to restart Karate. Now, this might mess up time temporarily, but it doesn't really matter for what we're working with. Okay. Next step, add resource management services on a master node. OpenHPC provides multiple options for distributed resource management. The following command adds the Slurm workload manager server components to the chosen master host. I like Slurm. Slurm is a scheduling software that users send their information into. It deploys their workload to the compute nodes and helps manage where there's free space on the cluster versus where there's not free space on the cluster, things like that. PBS is another one. Condor, I think, is still around. There are other options. I just like Slurm. I've worked with Slurm the most. It's simple to me, so that's why I use it. Okay, and then let's go back to the documentation because it's going to explain something about a use HPC provided file for starting Slurm configuration. So they have a little pre-built file. Let's do this and take a look at it. So we're copying the OpenHPC based baseline Slurm comp. So we'll copy that over. Now let's look at Etsy Slurm, slurm.com. So this is a general Slurm configuration file. This is the configuration file that lets the scheduling software know what the hardware is for the cluster, how it needs to do things such as allowing users into different things, stuff like that. And I see it's got this Linux 0. Our Slurm CTO, the host, is actually head node. Cluster name, we'll just call it cluster. That's fine. We're not getting fancy with it. Job submission plugins, launch type, mail, if it needs to send messages. Notice a lot of this is commented out because this is a very baseline configuration. Return to service, the PID files that need to be created, the ports that it needs to use, the Slurm user, state save location. So that's really useful for when you need to restart Slurm because it will keep track of its schedule even if you need to restart the service so that you don't make all of your researchers very mad. Use PAM for user accounts and stuff like that. Inactive linit, minimum job age, countdown timeouts, Slurmd timeouts, wait times. So for instance, let's say you're running a cluster and you've got a whole bunch of users that want to do a whole bunch of work, but some of that work is going to take more than 24 hours. Well, that's not really fair to everybody on the cluster. So you usually set a wait time or like a time limit. We're going core memory here for how it splits up the nodes, and that's really good for like mixed use. But anyway, the wait time is set so that if a person's job runs over 24 hours, it gets stopped, which is why you teach your researchers how to do checkpoints so that they know I only get 24 hours. I need to set a checkpoint as soon as I get to that 24-hour mark so that I can start my job again and pick up where it left off. And that lets you share resources better. Now, I will say I don't have any of that where I work because my researchers all have their own clusters, so they don't have to fight for wait time. But in big, massive clusters like your Ohio Supercompute or Access or there are large clusters all over the world that anyone can access. You pay money to utilize the resources. They have wait times and stuff. They have their end times set up. And then here's our node configuration info. So this tells it where the hardware is. So it's going to say node name C-1 through 4, sockets 2, cores per socket 8, threads per core 2, state unknown. And then you build partitions. Partitions are used so that if you have multiple types of hardware on your cluster, you can just simply tell the researcher, hey, use partition high mem for high memory jobs. So like those might be compute nodes that don't have a huge amount of cores, but maybe have 512 gigs of RAM, a terabyte of RAM, 2 terabytes of RAM, stuff like that. Use the GPU partition if you want to do anything with CUDA. So that might be where your NVIDIAs live. Use the general partition. There's usually a default. This one's called normal. You can see it's got a max time of 24 hours, set state up. It's the default, oversubscribe exclusive. So people can oversubscribe a node so that they don't have to share it. That's allowed here. I think that's allowed here. And then Slurm control D will be set for configurelessness or configless. That means that the config file won't be living on the compute nodes. They will reach back to the Slurm head node to say, what's the configuration for the cluster so that I know as well as you know. And it's in one place so you don't mess it up. And then again, we will probably change this from C1 through 4 to node. And then we'll change this to node. And it's going to be 1 socket, 2 core, 2 threads, 1 thread per core. This is a tiny cluster. And we're just doing it to kind of show how it's set up. This will not be a cluster that can actually do work. That's not going to be an option here, I'm afraid. And then you also set stuff in here. If you do have GPUs, you have to configure the type of GPU you have so that Slurm is aware of what kind of instruction sets it can do and things like that. So we got that set up. That looks cool. Let's go back to oh, I didn't show you guys that at all. I'm sorry. I'm so sorry. There we go. We'll go through it again. Cluster name, head node, scroll, scroll, scroll. PID files, ports that are important. Job age, wait time, backfill, contrast. As I said, this allows you to split up nodes. So a lot of times, if you want to do mixed up to allocated, so maybe you've got a job that only needs like 4 cores and 64 gigs of RAM, but all of your nodes are like 90 cores and 2 terabytes of RAM. You set contrast and you can split up the nodes to be able to do smaller jobs and share it, as opposed to that tiny job taking up a whole node. It will take up what's called mixed, and then other jobs can then go on that node as well. It's really cool. Accounting storage, blah, blah, blah. Here we go again. Node names. This is the configuration part of the file that says what the compute nodes are and what partition they live in. And like I went over a few minutes ago. That's just to organize and kind of keep track of everything. And again, apologize for not showing that a second ago. All right, let's go back to our documentation. Set up default C groups. Sure. We'll have to check this out because I'm not familiar with this piece, because I've never had to set up a C group, because like I said, my researchers do not share. Constrain core, constrain device, constrain RAM space, constrain swap space. All right, that's pretty decent. Default. That's about as default as it gets. We'll go back to our document. Identify resource manager host names on master host. So that line that I just changed. Now, if I'd set these variables up ahead of time, I could use this variable and just copy and paste this directly. But I did not. So we'll be modifying this line as we paste it in. You do not want to paste in this variable unless you have set this up. So we know it's head node. So now it's set that. So if we go into slurm.conf again, head node. I had already done it, but that command did it for us. Because I got a little bit ahead of the game there. Apologize. Variety configuration options. This is so true. This is such a big deal. Here, I will even copy this link and I will dump it in chat for anybody that wants to read a little bit more about Slurm. Slurm project provides an easy configuration tool that can be used here. And I'll paste that in as well if you're curious. There we go. We don't need that because our system is even more basic. S control reconfigure. Ooh, let's run that because we did make little configuration changes. Not that it knows about any of them yet. So that is telling Slurm, hey, I'm changing the way the node hardware is. Oh no, because it's not on. We're getting ahead of ourselves. InfiniBand, this is the InfiniBand information I was talking about. We're running all virtual machines, so we don't have any InfiniBand to configure, so we can skip this section. But if you are running InfiniBand, which is really just super fast networking, it looks different and it uses a little bit different software, but for the most part, it's just super fast networking. So no reason to freak out. OmniPath, we will not be using, so we can skip this as well. I recommend you grab it if you're going to be doing any of this stuff. Again, read the documentation to see what matches what you need. So at this point, all the packages necessary to use Werewolf on the master host should be installed. Next, we need to update the configuration to allow Werewolf to work with Rocky 9.4, update the host file, and to support local provisioning using a second private interface, refer to figure 1. Let's get our other interface configured and at least set up over here. So if we type in ifconfig, we're going to see this device and that device, ENS19. So let's go in there, edit a configuration, add now. I don't want to create one, do I? No. Oh yeah, I can do this. Wasn't it called ENS19? I hate this. I'm so used to the old way. I don't think it's in here. Oh, it is. It's not. Back in the old day, kids, this is how you configured your IF, your configuration files. You edited text. In you can do it. ENS19. I want to use that device. I think I can. I don't want to do that. I want to add an Ethernet connection. ENS19. It's going to be manually configured. It's going to be 10.1.1.1/24. We're doing a very small, very small thing. It's going to be the DNS server, and that should be fine. I should have changed that name. Edit. ENS19 internal. There we go. Now again, that is a dummy network. That network is not anywhere in my configuration. It is just a network that these devices are going to talk to between each other. And I think I just remembered what I need to change in Proxmox to make this work. But we'll get to that when we get to setting up a compute node, because it's really not that big a deal. Okay. And I didn't show you guys again. I apologize. All I did, I went into NM2E. I added a connection. I added one called ENS19. I manually configured the IP address, the gateway, and the DNS server, because it is going to be all of those things for that network. That is what that is going to do. And that's it. It's going to maintain and manage the network for the compute nodes and the head node to talk to each other. So let's look at our documentation, what we need to do. So IP link set dev, we just did all this. So this is actually turning on that network interface. These two lines are. Edit the Werewolf comp file to use the appropriate interface and settings. So ProPy. I don't like these. We're going to do it my way. So the first one is we're going to be editing Etsy Werewolf config. So let's just do that. This is the Werewolf config file. It's all JSON. So if you're comfortable with JSON, you know what to do in here. I do not feel like you need to dump a bunch of PyE lines like they show. Get in here and look around. See, it's already kind of got this set up. It's going to be this. It's going to be that because it's a dot. It's a /24. So for those that don't know CIDR, /24 is netmask 255.255.255.0. You would usually make it bigger in a real cluster because you would have hundreds and hundreds and hundreds of nodes. We're going to have one. So a /24 is overkill in itself. We are going to tell DHCP to start at .2 and end at 254. Even though we're not going to use all that many IP addresses, we don't want to take away the broadcast address and we don't want to take away the gateway. I don't know why it's set for .1 and .255. I guess you can do that. I wouldn't. I do this. So, and let's go over what else is in werewolf.com, just so folks are aware. So Werewolf is going to run on port 9873. Open that port on your firewall to your compute nodes, because that's what's going to talk to them. It's going to interface with user share. It's going to start up DHCPD services so that it can pixie boot your nodes to do the imaging. It's going to use TFTP boot to push those images. It's going to use NFS to mount the home folder and the op folder by default. This is a good default here. So what that means is it's going to take those two folders and share those to the compute nodes. And the reason that's important is when you run a Slurm job, the compute nodes kind of act like an extension of the head node. So they need to be able to see things the way the head node sees them. That's for SSH availability. It's going to make sure that etc resolve gets sent to the compute nodes. Paths that are configured, we're going to leave all of this like it is. All of that is good. We just needed to change the network. Now, all of that gets done via these commands, which took us, what, 5 seconds inside a config file? It's cool to use these commands. I'm down with this. No reason. We already did this. We already did this. We already did this. Let's see. Configure etc hostname on master and compute nodes. So this is kind of important. So this is going to put in the werewolf hosts file. So this file gets deployed on the compute nodes. We need to configure it to have a little bit of information so that it knows how to talk to the server. And we actually need to do one other thing. Let's go over here again. It's hosts. We're going to put that in here too. I don't think that'll cause a problem. It'll just, if you ping either one of those IP addresses, you'll get head node as a response. Again, I don't want to use those Perl files, so I'm going to copy this line that you can't see. Anyway, I'm going to copy this top line, and we're going to do it manually. Because it's okay. Yeah, so it just wants me to change anywhere that says werewolf into head node. And I'll do the other one the right way so you guys can see it. Copy. Right way, quote unquote. So it's just going to look for werewolf and it's going to change that to head node. And then if we open that file up, pretty sure there's just the one entry, but we'll double check. Head node. We'll do a where. Yep, just the only occurrence. So that giant line, that's kind of scary for folks that aren't familiar with using that kind of stuff, just to change one little word. But it's a clean way to do it. You can't mess up or touch the file the wrong way if you do that. Okay, next thing on the documentation. Bug fix. DHCPD template does not set next server. Well, we definitely need to set that. Now it's, I don't think that's right. SMS IP, internal IP address on the SMS server. Oh, it is right. Okay. So we'll grab this line. I don't know why on OBS it wasn't updating. I'm scrolling right now and it's not changing on the screen. Let me know if you guys are seeing me actually scroll. So this line leave the semicolon is we're setting the DHCP configuration of what the DHCP server is. And then our next line that's, wait a minute. No. It's not scrolling on my screen. That might be broke. We were going to enable werewolf. I mean, you can still see where I'm at. So the werewolf service is now enabled, so it will start on boot. And then the next line is to run configure all. So this command that I'm about to run is telling werewolf to get its configuration all squared away. So it's going to configure DHCP, it's going to configure the NFS services, it's going to set up the SSH keys, it's going to set up the TFTP service. Done. We didn't have to do any of that manually. It just does it for us. Pretty handy. That's why I like werewolf. And then it wants us to generate SSH keys, even though it did that. Let me see if I can show you guys where I'm at here. This line. And again, I don't know why this isn't scrolling. It really concerns me. Because I'm on the same. I think there's something wrong with my OBS. Okay. Anyway, it says to do this after running that other command. So there we go. Now the cluster is configured for SSH access. Cool beans. That's what we want. Define compute images for provisioning. Now this is where things get fun. I dig this. So Werewolf 4 supports using container images as the base file system for provisioning. They call it containers, but it's not like Docker containers. It's containers of images. They're kind of like Docker containers, but it uses the real deal Holyfield. It can import these images directly from an OCI registry like Docker Hub. Container images must be created specifically for use of Werewolf since they need to include things like kernel internet system. In an example, we will import our base image from a set maintained by the Werewolf community on the GitHub container registry. www.ctl container exec command runs the commands below. You can also, this is really cool too, you can import images you've built in other deployment systems into Werewolf. There was a bug with this recently, and they weren't worrying about fixing it until they realized that a lot of people actually pull this import feature in, and they were like, cool, we'll fix it. So I was really happy to see that. So we're going to do this. We're going to import an image built and maintained by the Werewolf folks. Once I click the right button. So that's going to go out and grab us an image of Rocky 9.4 maintained by Werewolf for the purpose of deploying compute nodes. I mean, we've basically already got the head node done, and we're getting ready to deploy compute nodes. And it's been, how long have we been streaming? An hour. So that's pretty cool. The next thing we're going to do is in Werewolf 3 and in other systems, you would basically root into the images, And then in that environment, you would run commands you need to do, like maybe you need to do patches or add repos, things like that. With Werewolf 4, you do what's called container exec, which kind of lets you dump things in. So let's see if this is updated yet. This is still not updating. I don't like this. I'm going to turn this on and take a look at this one. This needs to be, no, not that. There. Okay. I think that fixed it. Yeah. All right. Now it's scrolling again. So we did this command to import the Rocky image, or container as they call it. We'll try to use their nomenclature. And then we're going to run this command, which should give us sort of a bash prompt inside the container. So werewolf control, container exec, Rocky94, that's what we named it, bin bash. So give me a bash prompt inside that Rocky container. We're in. See how it shows the image here in Werewolf? This was the bug, basically. If you imported an image, you weren't able to run these commands because I believe it was something related to the system could only be mounted as write only. And there's a really simple fix out there on the website, on Werewolf's community forums that explains how to set it, or on GitHub, something like that. So we're in there. We're going to do two simple commands, so I'm not going to switch back and forth for the documentation here. The first one is going to add the OpenHPC repo. And again, we're doing this in the image, not on the head node. Much like what we were doing earlier. And then we're going to run, I believe it's DNF update. Yep. So we got to do updates. No big deal there. We pop in, we hit paste, bang, bang. And we wait for that to complete. Hopefully it's pretty up to date. I don't know how often the Werewolf people change their pre-built container images, but we'll see. Oh yeah, look at that. Super, super up to date. And then once that's done, we can, do we just close it? Define root location. So then we want to set this. Let me show you what I'm talking about here. So we built our image. You can add bin false as the last command to prevent the image from rebuilding. It will show an error. The rebuild later with the wwctl container build command. We want to build it though. So I'm pretty sure we just hit, is it just exit? Let's pop this over and take a look. It's either exit or control D. Exit, yeah. So now it's rebuilding that container with all the changes we made, which is what we want it to do. And now this next command we'll be doing is back on the head node so that it's aware of this, because we'll be using this for some other stuff, as you can see. Why? They're monsters. Why didn't they have us do all this before we exited? Why? Adding packages can be done by entering the image with control shell, container exec, or using a root, which I'm used to using a root, but I kind of like using the shell. So we won't define this because we really don't need it. We'll go back into it and follow the rest of these commands. We'll pull that back up. Yep. So there it is. It's rebuilt the image. Ironically, we're going to go back into the image. And then we're going to run a few more commands. So first we're going to add the HPC based compute because we are going to be making compute nodes with this image. Any questions, by the way? Don't feel like you can't ask a question or anything. This is as much a learning experience for me as it is for y'all. So let me know if I'm going too fast anywhere, if I miss anything. If anything's wrong with the stream, please let me know so I can catch it and fix it. I don't want this to be an an unpleasant experience. I want to make sure that it's a good experience. So speak up, let me know. Again, this is all for everyone else's information and entertainment. I'm just doing it. This is actually giving me good practice to remember how the crap to do my job when I get back to work on Monday. So by all means, let me know. Let me know if there's anything you want to see me do instead of what I am doing. Like if there's anything about this where you're like, could you show if we needed to do X, Y, or Z? So we needed to add the Slurm client to this compute image. So we'll do that. So that's getting added. And then we'll need to enable a piece of software called Munge and enable Slurm daemon so that when the compute images boot, those two services get started, which is really cool. So we'll grab the first one. Munge is I really don't know what it is for, but I can tell you how it works. Your Munge key has to verify itself against the head node before Slurm can properly talk to it. It's like an authentication piece for Slurm and your compute nodes and your head nodes. So we'll do this real quick. This is the one that turns on the Slurm daemon service so that it starts on boot, because if Slurm's not on, it's not going to do much. We will make sure the compute nodes all have cronny, which should be on there already, but maybe it's not. Oh, it's not. And then we will install lmod. Lmod is a really neat piece of software that I'm kind of surprised they didn't ask us to install ahead of time. But I'll show it off when we get to the point where we've got the head node configured and we're ready to install or mount software. So there's that all done. And then let's go back. Customize system configuration. I'm not planning on installing the Intel API compiler, so we'll skip that. Add InfiniBand, pass. So let me show you this stuff. These are all some additional optional software that you might need for your cluster, depending on the requirements that the researcher needs or the requirements of your environment, things like this. Again, if you're running InfiniBand networking, you need to add those drivers. We're not running physical, so we don't have that. Increased mem lock limits. I'm not going to touch that because we're not really doing anything. Restricting SSH access to compute nodes. This is the big one for me. I don't like my researchers SSHing directly to compute nodes because they can then skip the Slurm queue and not use the scheduler, which I don't like. They don't need to SSH to the compute resources, but there is a way to configure this to where if they have a job running, you can allow them to SSH to compute nodes to check on things. So if they're experiencing something that's a little weird and they want to take a look, as long as they're running a job through Slurm, you can configure it to allow them to SSH in that fashion. That's fine. That makes sense. We're not doing BGFS. We're not doing Lustre. I don't really care about syslogs because it doesn't matter for this. Cluster shell, that's just a way to send commands to all the nodes at the same time. So we'll probably do that one. I don't know what MRSH is. I don't know what genders is. I have heard of Conman, but I don't use it. And I don't know what GOPM is. So we're probably going to skip most of that. So skip this one. Skip this one. In order to nope, we're not doing that. Here we go. An additional optional customization is that recommended to restrict SSH access on compute nodes to only allow access by users who have an active job associated with a node. That's what I was talking about. This can be enabled via the use of a pluggable authentication module PAM provided as part of the Slurm package installs. To enable this feature within the compute images, issue the following command. So we're going to copy this, and this is going to be run on the head node, not on the compute node. But this will allow people to go from the head node to the compute nodes. If I would click the right thing. I'm so used to right clicking. Oh, we need to exit this first. We almost made a big mistake. Well, actually, hang on. Let's read this again. To enable this feature within the compute image. Okay, no, we do need to do this in the compute nodes. So I'm in the right spot. There we go. It's a good thing. I like to read twice. Go back to the document again. Again, no BGFS, no Lustre. Syslogs, I don't really care. Again, if this is important to you, do it. It's kind of important to have all that stuff sent to the head node because the compute nodes don't maintain a state for a long period of time. So if you're not sending those over, oof. Cluster shell is an event-based Python library to execute commands in parallel across cluster nodes. Installation and basic configuration, 3 node groups, admin, compute, and all. We're not doing that here. Genders is a static cluster configuration database or node typing database used for cluster configuration management. Other tools and users can access the genders database in order to make decisions about where an action or even what action is appropriate based on the associated types of genders. Values may be assigned, Yeah, no, my researchers don't make those kind of changes, so they don't care. Magpie contains a number of scripts to aid in running a variety of big data software frameworks within HPC queuing environments. Examples include Hadoop, Spark, HBase, Storm, Pig, Mahout, Phoenix, Kafka, Zeppelin, and Zookeeper. Consult the online repository for more information on using these scripts. Skip. Conman is a serial console program designed to support a large number of console devices. We're not running on PMI, so we don't need it. Node health check. This is important. I recommend you install this. I'm not going to today because global extension, open power management. We're not using any sort of physical hardware, so power management is not a thing. But I've asked people about this before, and I've gotten some mixed information. So there is a theory, or there is an idea that if your nodes aren't in use, they should be powered down, or go into like a sleep state, something like that. This can be automated in a way. So if Slurm sees that some nodes aren't really in use and there isn't a queue for them, it can kind of power down and give the adjustments here. The problem is, what I've heard is that this causes too much wait time for researchers. So they don't like this a lot of the times. I would assume if you configure it right, it's probably not too big a deal, but okay. Werewolf system includes, so we're done with the compute node stuff. We are on to the next section, which is not very well documented. Let's get out of our container to make sure that it gets finished and built. There it goes. Okay. We'll go back to our document. The Werewolf system includes functionality to import arbitrary files from the provisioning server for distribution to managed hosts through system called overlays. So it's basically you flag certain files that you want sent over to the compute nodes after they're built to help with whatever sort of configuration items that really can't be inside the compute image for whatever reason. Maybe they change frequently, or maybe you plan to change them frequently, and instead of having to go in and change the image and then reboot, you can change these and then just reboot without having to affect the compute image and worry about making any major changes there. So add the following to support unprivileged user namespaces for tools like Apptainer. Well, we're not doing Apptainer, so we can skip that. Similarly, we can configure Slurm and import the cryptographic key that's required by the Munge authentication library to be available on every host in the resource management pool, issuing the following. This we will do. So we grab this first command, which creates a directory that's an overlay directory called etc sysconfig. And then this next command will import generic. This is going to build essentially a Slurm daemon config file to tell it to reference the compute nodes or reference the head node when doing Slurm stuff. So let's show that off real quick. We want to make sure that this is set to 10.1.1, I think. Because at this point, we should mainly be using just the internal network IP address, not the IP address for accessing things from the internet. Anything related to the cluster needs to work on this network. And then next on there is configuring the Munge. So it's going to create a directory with some specific permissions called etc Munge. and then it's going to import etsymunch.key, and then it's going to set the ownership of that file to munch on the compute node, because it's already set as that on the head node, and then overlay generic setting the folder to belong to munch. Pretty simple stuff. So we'll go over that real quick. And then I'll show you kind of exactly what we're doing here. So there we've created that directory. And then we will gotta make sure we get the right line. Munch.key. And then we'll go to this. All of this stuff can stay. We don't need to make any changes. This is all specifically for Munch and nothing custom about it. And then this one. So there is the Munch key and the slurmd file configured. Now you're probably like, well, how do you know how to tell what files have been configured with the overlay? Now check this out. So if we do www.ctl, it's going to give us a bunch of information, which is super awesome. And you can always use help for any command. So if we do www.ctl overlay, which is what we're working with, and do help, it will tell us commands related to, or subcommands related to the overlay command. So if we do wctl overlay list, that's going to show us debug, generic host, and www.init. Now, if you remember, the commands we typed were going into the generic. So if we type wwctl overlay generic list, I think this is right. We'll just add the help commands list. We'll just do -all. That's going to show all the overlay files. So this is a bunch of stuff that gets configured by Werewolf. And then above it is host stuff that is also configured by Werewolf. And then generic is where we were setting stuff up. So if remember, we created a folder called etsymunch. We imported a file called munch.key and set permissions on it. We also created this etsy sysconfig directory, and we created a file inside of it with a command with information about setting up Slurm. And that's pretty cool. So you can also do this with other stuff. So let's go back in here. Container lists. There's our Rocky container we built just a few minutes ago. No nodes set up yet. So we're getting to that piece. Let's go back to our doc and see what's next on the list. Finally, add optional support for Werewolf to control InfiniBand, which we're not doing. Finalize and prefiguring. So now if we needed to build our container, we would run this command, and then we have to run this command. Our container should be built, but we'll go ahead and run this anyway, so you can see kind of how it works. It's not very exciting. So it's going to go through, same, it says, no, you've built the latest version, don't worry about it. And then we'll go grab the other command. This is going to build our overlays. Now what that means is it's going to apply the changes we added to overlay to make sure that they get added to the nodes when they get provisioned. Done. All right, what is next on our list? Registering nodes for provisioning. Nodes can be registered for provisioning using the following syntax. So for I equals 0, I less the number of computes. So it'll do this for everyone. That's kind of infuriating for me. And we only have the one. So we're just going to build it ourselves. We do need to get this though, which leads me to going back and fixing what we were working on before. So back over on our Tiger host 2, which is where we've configured stuff. We've got our node 1, and we even have its hardware address. Yay! But we have the incorrect networking here. We need to build a fake flat network. No big deal. We just go in here. Oh, we got to do it at this level now. Yeah, I think we just do this. Yeah, I think this will work. We'll just call it HPC net. Tag No, let's do tag 100. It's not VLAN aware, it doesn't matter. And then we go up to SDN and we hit apply. Things complain for a second as we add networking to both hosts. So in case we wanted to spin up compute nodes on the other ones, though I'm not sure how that would work without there being a real network. We won't be testing it. Okay, so that's done. So then we need to go here. We need to go to this and we need to edit this and change it to HPC net and hit OK. And it's going to be fine with that. And when you go to this one, we need to go to this and we need to set this to HPC net. Again, it's a bullshit network. It's not real. Is there an easy way? Yeah. So we want to get that line. And we're going to paste it in here. And we're going to go to, let's go home. Let's do nano mac.text. I don't want to lose this line. I'm going to need that. Because we need it for this line right here. So we're going to steal this wonderful little middle section. Actually, we're just going to manually type it. So give me a second here. wwctl node add -- container equals rocky -9.4 -- IP ADDR equals, we're going to give it 10.1.1.2 -- HW ADDR equals that MAC address. Can I just paste it again? Haha, I saved it. And then it's going to be called node 1. So let me show you what I did. So instead of that weird line, which you should use if you're spinning up a whole bunch of nodes at the same time, I just typed in a single line that tells it what IP address I want to give it, what its hardware address is, what its name is. So if we do wwctl node list, we will see it. There it is, node 1, default. Groovy. Let's go back to our doc. So we registered the node for provisioning. We're not doing InfiniBand. And then we've just got to do overlay build and set a configure all. And then we'll start merge and slurm on the head node. So let's do the first thing. wwctl overlay build. Bang. Now it is building all the stuff for node 1 specifically. And then the next line, configure all to make sure that node 1 gets its configuration info. Bang. So it's setting up DHCP for that node, making sure that all the keys are copied, TFTP is set up, things of that nature. La-di-da-di-da. Then we go to, we're going to enable the munch service on the head node so that it's started and running. So when the compute nodes boot up, they get seen, and that they can be verified. And then we'll enable the Slurm service as well on the head node. Scroll, kernel arguments, blah, we're not doing that. Boot compute nodes. All right, so let's go back over here. And if we've done everything right, which I don't know, we've gone pretty quick here. I'm a little nervous. This should boot. Let's make sure the boot option is net first, because really that's what it needs to do. If this network is configured correctly, I'm not making any guesses that it is because I've completely forgotten how. We should see this VM turn on, wait for a Pixie server. Oh my God, it found it. And then it's going to grab the image from Werewolf. Unable to mount rootfs on unknown block. We got pretty far. I'm surprised we got here. What did we miss? Kernel panic, not syncing VFS, unable to mount root file system on unknown block 00. Okay. Deprecated hardware is detected. QEMU virtual CPU version 2.1 will not be maintained in a future release. So we ran into an issue where it can't mount the hard disk. Let me take a look at something. So let me show you what I'm doing here real quick. There is a command called wwctl node status. So if you need to check on the status of your nodes, like when the head node is last talked to them, things like that, what it got stuck on, information, it will kind of show you this. Now, I've done something Linux stupid, it seems. So let's go back over to this and see what the heck is going on. Not seeking views. Unable to mount root file system on unknown block. Is this related to my CPU? Might be. Let's turn this off. Let's go to hardware. Let's try this. Yeah. We'll add an EFI disk. I don't think. Just do whatever. I don't know much about that container image. It's one that we downloaded from Werewolf, so I need to make sure that I'm offering up everything that it is expecting. Failed to load boot to Wi-Fi. Station IP address is 10.1.1.3. It shouldn't be. It should be 10.1.1.4. Okay, so it didn't like that. I don't think this matters. Again, it's expecting physical hardware, so there might be a problem. Let's turn, so we changed the CPU architecture. Let's change this back to CBIOS. And I think this is fine. Oh, you know what? I wonder if I need to set this. No, that's good. That looks fine. Let's see how this goes. We're pixie booting again. That's good. So it likes this version of the BIOS, no UEFI. It grabs that info. I just wonder if there's something weird with that compute image that I just don't know about. Instrument FL, not weird, like different for what it's expecting. Kernel panic, not syncing. VFS, unable to mount root file system on unknown block 00. Unknown block. Let me Google that real quick. Unable to mount root. That's not unknown block. Hey, look at that. First result. Stack Exchange nonsense. Two common concerns. This kernel doesn't support the cell system on the device. If you compile your own, there is no. Feel like we're missing something from the documentation. let's go take a gander at their compute images. Just in case the one I grabbed is really for specific use cases that don't fit my silly use case. Right here. This is a Docker container, so I'm betting it is weird. I wonder if Werewolf has other containers I can just quickly import. Because I could make one, but I don't really want to. Most containers in Docker Hub are not bootable in that they have a limited version of systemd to make them lighter weight for container purposes. For this reason, don't expect any base Docker container, Docker/Rocky Linux or DockyDippin to boot properly. They will not, as they will get stuck into single user mode. The containers in Hub, Docker, Werewolf are not limited, and thus they boot as you would expect. Deprecated. Deprecated. These are all listed as deprecated. Current Werewolf node images are now pushed automatically to ghcr.io. Hey, and that's the one we're using. Recently tag image. I see. Install command line. Docker pull. So that's what's going on here, is that this 100% is using a Docker image that I'm just not familiar with. That's not a big deal. Or at least it's calling it a Docker image. Now I could, what could I do here? I don't want to use specifically a Docker image. Well, all right, we can adapt. So let's go back over to our SSH session. Let me get you guys back over here. So if we do www.ctl container help, this should give us pretty much all the information we need. Container import help. I think I can tell it to, yeah. So if I do, I need to get the Rocky 9 ISO on here, and I think I can do it that way. Yeah. Import containers are used to create bootable FNFS images. I'd like to see what's going on now. Let's poke around this virtual machine a little bit more instead. We're way ahead of what I thought we would get to, so that's kind of cool. I don't think I have to do any of that. Let's read this again. Just throwing me for a loop. Unable to mount root file system on unknown block 00. Okay, so it sees that device as 00. I'm assuming it is this. SCSI 0, disk 0. Yes, it doesn't like this. I wonder why it doesn't like it. Well, we could change it. Detach. Blah, blah, blah. Oh, yeah. Better shut her off. Stop. So we're going to try some manipulation here. Let's disk action. No. Edit. Let's try doing it as a SATA device. Just to see if it can see it as something different. This may just throw it an error again. We'll see. I do think I just need to read more about that image to kind of understand what it expects. If I'm gonna, if you were gonna use something like this, it's really more of a you making sure you set things up right for the image you're using, or you build your own images. We're using same thing. Unable to mount root file system. I don't need you to mount a root file system on that device. You're provisioning. Now let's stop it. Tweak this again because I meant to give it 2 cores. I don't think that's going to matter. I don't think this is going to have anything to do with it. Go again. Let's watch it fail. This is the part where you guys get to laugh at me. Tell me I'm doing it wrong. Oh. But we've got provisioning working. It's just, it doesn't like the machine I'm sending it to. Yep, that's another fail. Same problem. Kernel panic, not syncing. VFS, unable to mount root file system on unknown block. This because, oh yeah. Should probably do that. I don't know. We'll see what happens. But I don't believe this is anything to do with the image I pulled. It's really more of me figuring out how to set up my virtual machine. Because again, usually you do this on physical hardware. Nope, failed again. Oh, look at that though. Unable to mount root file system on unknown block 00. It's acting like I need to pre-format these drives. Which again is weird to me. That doesn't make any sense. It shouldn't matter what's on there. It's not gonna last forever. That's not gonna do anything. I'll think. I'll give it a shot. This is all me not knowing what these images are expecting from a VM version of a system. Because again, I've usually only used my own images. I've never pulled one down from Werewolf. And of course, I do recommend that if you are going to use this, to hop onto the Werewolf Slack. We could reach out to them right now and be like, hey, I'm getting this weird error, and people will know exactly what's going on. They'll be like, oh yeah, you just need to do this. Which is cool. I don't think I need to change this. It's fine. It's fine. Fine. Can that one? Oh, wow, it can. I don't want to change that. VM state storage. What? Yeah, whatever. Storage is fine. And I know I can boot systems, but something... Intra-MS unpacking failed write error, so it can't write. Let's take a little look. That is from 2 years ago. Nope, nope. How old is this stupid document? I am digging around the internet to see if there's anything worth referencing. All I can tell is it does not like the hard drive layout. But you don't configure that on the host. Well, I'll have to look that up. I'm not going to sit here and bore people with that. Let's take a look at what we've done. So we've built a head node. We have a compute node. We're running Werewolf 4. We can look at our node status. It's failing. We know that. We have... Oh, wait a minute. I feel like there needs to be a kernel in here. Did we miss that part? I don't think that was in the documentation. Add OpenHPC components, blah, 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 blah. System config, yada, yada. Install root, yada, yada. Memory limits, yada, yada. BGFS, yada, yada. Cluster client, blah, blah, blah. Reporting system logs. File. Werewolf provision of the node with an image customizes overlays, selection outlets, creation of the node overlays. Register node for provisioning. We did that. We did that. We did that. Yep, no, they don't cover any of that at all. Anyway, let me show you some other stuff that we have going on. Is this installed? Okay, it's not. So, one thing that I wanted to show off was Spack. DNF national install Spack OpenHPC. They have an OpenHPC version of Spack. Spack is a neat little piece of software. Because it works like DNF/YAM in that you want to install a piece of software. You can get it to grab a bunch of kind of default stuff. The trick is knowing what kind of extra compilers you might need to add, because stuff will fail if you don't know what it needs to compile with, and it doesn't really tell you. So if you do Spack list, what? It installed it, but I don't have the command. Spack OpenHPC. Module. So this is called lmod module. So this lets you mount stuff. So if I do module add Spack, Spack has a bazillion trillion things in the world added to it. This is gonna run really slow. Yep. Let's see. Spack info. What is something I install? Someone freaking out. Python. So it will tell you different versions, preferred versions, safe versions, deprecated versions. This comes in handy when you have a researcher that goes, hey, I need this version from 15 years ago because it's the only way my code works. Please add it. You can do that. You can also flag different stuff. So there are default variant configurations. And it will say what it needs to add. So if we wanted to install the preferred version, we could just type Spack install Python. And then we would have it. If we needed a different version, we just add an @ symbol and this version number. And it will install that. But let's install Python and just see what it does. We're leaving it all default, and we're letting it do whatever it needs to do to figure out how to get to that default install. Sometimes this works fine, sometimes this fails. Boy, this head node is slow. I better give it some more resources. Yeah, golly, it's chewing away on that. Usually Spack talks a little bit more. Kind of surprised it's just sort of sitting there. It's just sort of trying to solve stuff. We'll give this head node more resources at some point, if we want to keep going with this kind of stuff. I do want to figure out, I'm going to figure out why that compute node stuff isn't working and figure out how to fix that. So here we go. It's going out. It's fetching the stuff to install Python. You might say, well, why didn't you just do DNF install Python or pip3 install Python? The reason you do this is you can install, this helps you manage multiple installs of software. So if you have multiple researchers using different versions, but they need the same software, you don't have to go through that headache of remembering where to do different things for compiling or, yum install special commands. Spack will take care of all that for you. It will go in, and I think this one is even going to, it may put this in the opt folder and it might put it in my home folder. I'm not really sure how this default one is configured. I highly recommend you go to the Spack site and kind of learn how to configure it so that you know how you want it to work. Like, you can have it work in a situation where users are allowed to install their own software, which adds a whole bunch of extra bloat sometimes, especially if you got like 20 users that all use the same software. If they all install their home folder, it's 20 versions of the same piece of software at home. Just do it for them. Or again, doing it for them. That's what I do currently. There is one Spack install. You have to have sudo rights to use it. And it puts it all in one central location. And then the module system, and even the Spack system, the Spack comes with kind of a module system as well. It will scoop it up and make it available to users. And then you can configure stuff like my default packages. When I log in, I want to make sure this is loaded and that is loaded, make sure Python's loaded, make sure Spack is loaded, make sure Slurm is running and all that. You can do Slurm via the package system like this if you want to, in case there's some reason you don't want a, I don't know, single consistent Slurm install. I've not run into that, but I guess it's a thing. And then, yeah, we've pretty much built an HPC cluster. Now, obviously our provisioning isn't working. We just need to figure out why that container isn't the way it needs to be. I guess it's expecting something. I don't know. I'll have to look into it. Again, I'm used to just pulling in pre-built images that I've already had, or doing it the Werewolf 3 way, which I think just builds one off of the ISO or off this main machine. And I can show that off in another video. That's no big deal. But the head node is done. This is the hardest part, really, is making sure that your head node is configured and can talk to your compute nodes. But that's working. It is able to talk to the compute nodes. The compute nodes just can't provision, so they can't talk back yet. But that's usually the least of your worries. You want to make sure this is up and available to users so they can get their data there. Ooh, excuse me. And all that jazz. Well, according to their documentation, it should just boot. Head base node. That's exactly the line I used. This will pull a basic node image container from Docker Hub and import the default running kernel from the controller node and set both in the default. Okay. That might be where our problem lies. This bad boy is not running the same version. Yeah, we're on 9.5. I think we found our problem. So I think the kernel version on my head node is not compatible with their container. And it is using that kernel as part of the container deployment process. So that might be where I'm running into the issue. I'm looking at the Werewolf default configuration info to see if maybe we can use a different container. And I'm building that right now using the same commands we used previously. Now, if this does work, we might be able to provision, but I'm not making any container changes, so it won't function properly with the cluster. Go. Let's see if this works. I might not have done everything I needed to do, so this might fail again real quick. Yeah, that's okay. I think I've got to do... Yeah, there, it changed it for node 1. All right, let's see if that maybe fixed it. Probably not, but I think I found out what the problem is. Not 100% sure how to change it, but I'll figure it out. And then while that's going, that's still building. That'll take forever. Dang. Okay, that wasn't it either. All right, we'll have to figure that out. I'll show this off a little bit more, just so you kind of get an idea of what's going on here. So when you tell Spack to install a piece of software, Python for instance, if you just tell it the defaults, it's going to go out, build all these dependencies, link these dependencies, and start configuring them as little sub packages inside the Spack folder area. So, and it puts these little weird things on them. I think there's a way to clean that up, but I'm not 100% sure. I think this is for uniqueness so that each user can have different ones. And I think you only really need like the first 4 or 5 because it's so unique and changing. But it's grabbing every dependency and installing it so that they're isolated specifically to that version of software. It's kind of containerizing software installs for an environment, much like you do virtual environments for Python itself. You don't just install a bunch of stuff into Python. You build a virtual environment for, maybe you want to do a bunch of Python math related things. You build a little virtual environment for that. Maybe you want to build a Python virtual environment for gaming. So you have your gaming modules and then you pull up that virtual environment when you want to work with that set of Python commands to keep things clean. That's what Spack's doing for us here. It's configuring all these different pieces of software to make sure that it's keeping everything clean for the user and so that they know this version of Python is using these versions of the software that are dictated as the dependency requirements, and I can manipulate them without worrying about messing up anyone else's work. That's what that's for. And that's kind of it. We sort of did it all other than getting the compute node to provision, and that's definitely a hardware issue on my end for some reason. I'm not sure what's going on here. I'm gonna have to look at this some more. But yeah, it's so mad. So very, very mad. Blah, 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 blah. We're not doing that. And again, this is all stateless provisioning. That's why I'm a little confused here. We don't really install anything. You just kind of spin up the machine. Mm. Wait a minute. Did I shoot myself in the foot? Let's see what this does while we're still waiting for this to complete. I'm going to keep trying to see what's going on with the compute node. Okay. Hmm. No, no, both of those are. Oh, it didn't switch it. Okay. Hmm. Did all that, did all that, did all that. That's what we need. Node set. Can barely read this. I need to duplicate this tab. No, not that. Node set. Oh, I need to see that. What? Oh. This is what happens when you go down the rabbit hole and you start just poking away at things. Show me the container list. Yeah, it's still set through that. WCTL node set dash a dash dash container equals Rocky Linux dash 9. Yes. Okay. Is it WCTL configure? Now, I'll take you back over here. We are finally at which package are we on now? Tar. And it's 25 and 29, so we're close. I still don't think this is going to work, but we're going to see. Nope, still failed. That's fine. That was a bit, this doesn't have a. Oh, I never. One other thing I'm trying is maybe it needs more RAM for the compute node. So it has somewhere to store the data because the image is 2 gigs. But I don't think that's it either. But we're going to see. If this works, I will switch screens. But I'm pretty sure I'm just an idiot. Oh, you know what? I think that was it. So I'm a big dummy dum-dum. As you can see, it is now pulling the image, and it's the wrong image because I thought our image was broken. But it was really because I wasn't setting enough RAM for the compute nodes. Because again, these things are supposed to have a ton of RAM because they're huge. But it needed RAM to actually put storage, you put the OS into storage. So now we are properly provisioning a compute node, and we're really done. We will switch the compute node to the right one and reboot. Yeah. Ta-da! So this is it doing internalization. Dependency failed for mount WW4 disks. Doesn't matter. There we go. Now we have our node 1. Now if we go back over to our head node, we'll switch over to this guy. Node status should be green. Green. That's awesome. But we need to change that command. Oh, you guys can't see this. Green. We need to set this to container. Rocky-9.4. Yes. Then we'll just, for the sake of argument, configure all real quick and overlay build real quick. Awesome. Let's go back over here. Let us stop this machine again. Let's tweak this a little bit more. Let's give it 4 cores, and I really wish I could do this better. What is it? 8192 for 8 gigs of RAM? Yeah. Sorry, I was changing hardware. Nothing exciting. Let's make sure it pixie boots with the right image this time. And then we should be able to check Slurm. Where's our image? Rocky 4. Yeah! We figured it out, everybody. We did it. We have fully configured an HPC cluster. Now that is currently set as the default image for all nodes. So any additional nodes I add will default pull that image. I can also set configuration overlay defaults for stuff like net masks and gateways so that they will always pull the same info by default because they are all the same. And for folks wondering about Werewolf, specifically user guide, that is here. Throw it in the chat. And for the Spack documentation, that is here. There we go. That's about it. So there's our node. Now, if we go over to our head node, bring our SSH session back up. SQ, no jobs running. sinfo-ln. Do you see it? You do see it. And it's not available because it's technically not configured, right? That's okay, though. Available features, null. All good there. Is it up? Stat idle, yep. And we can even SSH node 1. We can jump over there. And now we're on node 1. So if we do free-m, there we go, 8 gigs of RAM. Tiny little 4 gig partition because it's running in the RAM. So we are using near nothing. And as you can see, we have mounted /home over here. So there's that. If we do module avail here, we're going to see Spack, Pixmix, HWLock, CMake. Now, if I do module add CMake, and you can use tab here. Now, if we go back over to node 1, we should see both of those mounted now? No. Yeah, it's supposed to be mounting /opt. I wonder why it's not showing up. Oh, it is. Okay. It just doesn't show up in DFSH. Interesting. Well, let's take a little look here. I don't trust this quite yet. Okay, they're in there. But that's it. We're done. This is really boring. It's going to take a while. 3 more packages to go still. Mainly because the head node is really slow, but under 3 hours, we stood up an HPC cluster that could technically be used to do scientific research. Now, I wouldn't, not this one, but we did it. That's going to be it. Thanks everybody for coming by. Thanks again. Leave a like if you liked it. Subscribe if you're a new viewer. Let me know if you're a new viewer. Leave some more comments down below. Let me know if you enjoyed this live stream version or if you think maybe I should stick to the more quick cut sort of simple videos that I cover. All the feedback is more than welcome. Give me the hate, give me the love, give me whatever. But welcome to 2025, and I hope you have a wonderful year, and I hope I have a wonderful year. And I guess we're going to call it the end here. So have a wonderful rest of your Saturday, everybody. Take care.